K10 notes. Linear and quadratic equations and inequalities applications. So, our goal is to create and solve linear and quadratic equations and inequalities. We're dealing with story problems. Here are some suggestions. Read the problem all the way through. Then read it again. Define your variables. We've been talking about that on the whole unit with word problems. Sketch a picture if possible. Identify any constants that might be added, subtracted, multiplied, divided. Write the equation or inequality, and then solve. Here are some reminders. Consecutive integers are numbers like 5 and 6. So if x is 5, then x plus 1, 5 plus 1 is 6. If they're consecutive odd or even, like 6 and 8, or 5 and 7, well, 5 plus 2 is 7, 6 plus 2 is 8. Therefore, we use x and x plus 2. Percents, remember, change them into decimals, to the left, 2 spaces. Area of a rectangle, and projectile problems. This formula, remember, h of t, whoopsie, that's our height, as according to time. As time changes, height changes. Negative 16 is a standard here, t being time squared. VO is our initial velocity in front of the t. So if it launches at 30 feet per second or something like that. And s is the initial height. Now, these are such like a vocabulary list of words that mean add, subtract, multiply, or divide. Don't need to read through those. Is typically means equal. Is less than is usually a less than sign. And is greater than is a greater than sign. Of course, remember, those can go either direction. So, some examples. 2 consecutive integers sum to 45. So, I'm going to call my first integer x, and my second integer, since they're consecutive, x plus 1. It says that they sum to 45. So that's 2x plus 1 equals 45. 2x equals 44. X equals 22. Plug it back in. My numbers are 22 and 23. Allie's age is 10 years less than Maddie's age. Always look for what is 10 years less than twice Maddie's age. Always find what's being compared to. Maddie's age is our starting point. Now, Allie's age is 10 less than 2 times Maddie's age. Now, Allie is 24. How old is Maddie? Sorry, I didn't mean to do that. So, whoops. I meant to say here. Allie is 24. So, 2x minus 10 equals 24. Add 10 to both sides. X is 17. So, answer word problem with words. Maddie is 17. And once again, you can check it. If you double that and take away 10, you get 24. All right. Susie's going to the fair. She wants to spend less than $50. If it costs $12 to get in the fair and $2.50 a ride, what's the maximum number of rides she can go on to? Well, what we're trying to find out is rides. Now, we know that it just costs $12. That's our constant just to get in. This goes back to the problem we've been doing with delivery fee or the fee to hire the caterer. It's just a constant. Plus $12, sorry, my bad. Already did that. Plus $2.50 per ride. And she can only spend under 50, not less than or equal, but under 50. So we're going to subtract 12. You get 2.5x equals 38. Divide by 2.5, and x is 15. So 15 rides maximum. Number 4, certain math teacher likes to buy her toilet paper over the internet each month. Her favorite brand costs $12 a package plus $5 for shipping. She doesn't want to spend more than $100. What's the maximum number of packages she can buy? So X is going to be our number of packages. The $5 is a constant. It just costs $5 to ship. Plus, it's $12 per package. And she wants to spend less than $100. So we subtract $5, and we get 12x equals 95. So we divide by 12 and get x equals 7.916. Now, this is one of those real-world problems. Normally in math, we would say round up to 8. So let's see that. Let's test that. $5 plus 12 times 8, less than 100. Well, 12 times 8 is 96, plus 5 is 101. Is that less than 100? No. So unfortunately, unless she wants to bump up her budget, she can't buy 8. We have to actually round down, so we don't have enough money for 8 packages. So she's going to buy 7 packages. So remember, we don't always follow rounding rules in the real world. Okay, quadratics. The product of 2 consecutive odd integers is 99. So my first number is going to be x, and my second is going to be x plus 1. Because they're odd integers. Sorry, x plus 2. They're not consecutive, they're consecutive odd. So like 7 and 9. And it's going to be a product, so I'm going to multiply them. And it equals 99. So that's x squared plus 2x equals 99. We need to move this over and get x squared plus 2x minus 99 equals 0. And now our old favorite factoring comes into play. I need 2 numbers that multiply give me 99 that differ by 2. Hopefully you know that's 9 and 11. But I want more positives than negatives. So I set these both equal to 0. And I get x equals 9 and x equals 11. Sorry, negative 11. Now, I plug 9 back in. 9 plus 2 is 11. That's one set of answers. If I plug negative 11 in and add positive 2, I get negative 9 and negative 11. That's another set of numbers. They're both odd. It says odd only. It doesn't say odd positive. So 9 and 11 are positive odd numbers. They're consecutive. And negative 9 and negative 11 are negative odd numbers. Okay, this one you definitely need a picture for. This is a classic problem. You have a garden measuring 12 feet by 18 feet. I'm just going to move this bad boy. Nope. Hold on. Right inside. You'll see why. 12 feet by 18 feet. Now, they want to have a pathway all the way around increasing the total area to 616 feet. So, we want the area, which is length times width, of the big structure to be 616 square feet. Now here's the problem. We don't know what this width is. And we don't know what this width is, or this width, or this width. So, this is 18. It's not plus x. It's actually plus 2x. And then this is 12 plus 2x. So here's where the work comes in on this problem. My length and width is 12 plus 2x times 18 plus 2x equals 616. So this is going to be a little bit lengthy, a little bit of work. It's okay. First off, I'm going to FOIL. But since I know I want to have my x squared in front, I'm going to rewrite this as 2x plus 12 and 2x plus 18 equals 616. Let's clean that up. I'm not going to do that. Now, so when I FOIL, my x squared will be in front. 4x squared plus 36x plus 24x plus 216 equals 616. Now I'm going to do two things at once. I'm going to combine these two, and I'm going to subtract 616. That's going to give me 4x squared plus 60x minus 400 equals 0. Now, before I try to factor this bad boy, I want to make my life much easier by taking out the GCF. We always want to try to do that. And 4 goes into all these numbers. So I'm going to get x squared plus 15x, much more manageable, minus 100 equals 0. Now I'm not going to need that 4, so I can technically divide both sides by 4 and get x squared plus 15x minus 100 equals 0. And now I'm just looking for two numbers that multiply to give me 100 that differ by 15. Now this might take a little bit of time, okay, because you got numbers like 1 and 100, 2 and 50, 4 and 25, 5 and 20, and 10 and 10. And you got to test those. Okay? I usually start, again, towards the less extreme, so let's try 10 and 10. Well, that's going to give me, they got to be plus and minus to get a minus. That's going to make the middle term drop out. Because I'm going to get 10x minus 10x. So that can't work. So now I'm going to go to my next numbers, 5 and 20. Let's try that. Well, that's going to give me 5x and 20x. If I subtract those, I get 15. So I want plus here and minus there. Not too bad. Now I set these both equal to 0. and I'm going to get x equals 5 and x equals negative 20. Now, can I have a measurement of negative 20? No, I cannot. So that means, there's my answer. The sidewalk is 5 feet wide. And the beautiful thing about this problem is, if you wanted to take the time, you had the time, you could actually put that in. So if this was 5, that's 10 feet, right, total? So that would make the 12 become 22, and the 18 become 28. And if you did 22 times 28, guess what you're going to get? 616. That's it.